are with us. And thank you for the introduction. So the session today will be about transforming your architectural practice into the AI age, AI's impact on practice, ethics, and regulation. And this is a health, safety, and welfare session. So I'm going to talk about AI and architectural design, more of HSW, health, safety, and welfare. But I'm also going to tell you that through my personal journey, trying to create AI design tool for architects that will improve. And let me start. So thank you, Stacy. The introduction, I think, was really great. And I founded arcdesign.ai. We're already over 10,000 users from over 100 countries. And I gave this talk at the first time at NCARB, first ever Future Symposium. And that was when NCARB really, and I think everyone started to understand that our industry is going through major disruption, major transformation. And we are the one who actually creating this transformation, and it's on us to make sure that this transformation will be healthy and safe and will improve our profession. Now, this talk was together with Phil Bernstein, the Dean of Yale Architecture School, that actually told the perspective from the academia and brought the academia perspective. John Locke from Autodesk, the chief research scientist that gave his insights about the research that enterprise like Autodesk is doing and the future that they think our industry will have. And I was representing the small companies that are actually in the process, in the journey of improving and disrupting our industry. And so this talk is based on that talk that was last year. And I started the journey by reading the McKinsey report. Now, in 2017, McKinsey came up with a report about our industry that was very, very interesting. It's a very long report. Whoever will have time to read, I really recommend it. And it's called Reinventing Construction, A Route to Higher Productivity. And I'm talking about 2017. But as you can see in the United States, the labor productivity in construction has declined since 1968. In contrast to so many other trades, so you can see agriculture, manufacturing, even overall economy, and the orange one is the construction one. And you can see how low it is. And going through other metrics globally, labor productivity growth lags behind that of manufacturing and the total economy. So look how much behind we are. The orange is the construction industry. And so also starting to analyze these numbers and thinking about the potential of global productivity improvement from implementation of best practices. So if we talk about, of course, the regulation, that it's the enabler, starting from there, of course, and then diving to collaboration and contracting. Then our design and engineering can improve productivity by up to 10%. That's a lot. And if we're talking about other parts, procurement and supply chain management, on-site execution, technology, up to 15% only if we implement and increase the technology aspect of our profession. So capability building, and you see the cumulative impact, it's up to 60% that we can improve the productivity in our industry. And fast forward to 2024, unfortunately, and I think a lot of entrepreneurs and a lot of people and architects and people from the industry read this report, but still 2024, why the construction industry must climb out of its productivity rut and why it hasn't yet. So this transformation that we talked about in 2017 still doesn't have any impact, and we don't really feel it in our practice. And so more on a 2024 report says most construction players have not yet adopted at scale productivity innovations, many of which offer increased control. So if we divide it to productivity improvement, so cost and time decrease, productivity, and increase control of the process and risk. So as we see, it's a bit better and widely adopted, more on the digital, documented, and contract management. So more control of process and risk. But if we talk about frequently adopted, we can see more prefabrication and modular. And we see also in the increased control, we see 5D building information modeling. So that's a rapid design concept for evaluation. And then if we talk about selectively adopted, then we can see the 3D printing, and we can see the AI, which I'm going to talk about today. And we talk about generative design and scheduling. And so pre-directive maintenance, road optimizations, resource management, automated safety, and quality control. So apparently all that is still selectively adopted. And if we're going further and we want to look on the current trajectory, construction output might fall short of demand by 40 trillion by 2040, according to McKinsey 2024 report. And these are the numbers. So we are all facing a great challenge that we must improve the way we work. And if we're talking about labor productivity in construction continues to lag behind productivity in manufacturing and the total economy. So if we look at the 2017 metrics and graphs, we're still really behind. So we have manufacturing, we have total economy, and construction is still lagging behind. And when I started this research in probably around 2019, so about over 5 years ago, what I read about mostly at the beginning was the modular construction. And I'm sure a lot of you are familiar with that. And we were kind of, the team and myself, we were surprised that modular construction was not widely adopted and very popular. And this is, you can see in the picture, that's a building by Shop Architects in New York City, in Brooklyn. And that's considered actually the tallest modular building. And going to research more deeply why it wasn't adopted back then in 2017, 2018, we found out that it's a great concept. It's a beautiful concept that you actually build everything, the units, if we're talking about multi-family projects or other type of buildings, everything is being planned and built in the plant, and then brought ready-made into the job site, in the construction site. And the two reasons that we found out that we believe it wasn't adapted in all over the industry was that if we talk about the efficiency of urban buildings, then because of these units, you can see they are self-sustained, structurally self-sustained, then the walls and the floors need to be structurally sustained, and therefore they're much thicker than regular buildings. And so we lose a lot of aspects of the building, because, you know, it can be shorter floors or shorter buildings and then smaller areas, and we lose a lot of air rights and spaces in the building. The other reasons that we found out was that those buildings were not structurally well built. And so that was a major problem when the safety of the occupants, the safety of the public was not maximized, and that was a problem. So that's another building, an affordable housing building in New York City that was tried to build with a modular construction, and it was a senior housing project on Linden Street in Brooklyn too. And again, I think the problems that we found out was also again and again, also in the process of this building. And so I also would like to send you or invite you to join me to the beginning of my career. I started my career in Florence University in Italy, and studying in Florence University is a lot of Renaissance studying. And all my researches as a student was about Renaissance masters and Renaissance architecture. And one of the dissertations that I focused on was Leon Battista Alberti and his theories of harmonic music. So Renaissance men were not like today, that we're architects and we're creating architecture or designing building or, you know, doing other trades that we specialize in. Renaissance men were multidisciplinary people. They were architects, they were artists, they were historians, they were researchers, they were mathematicians. So they really included all of these disciplines. And I think for me, that's what really created, enabled the creativity, the transformation of that era. And so a lot of the things that are happening today reminds me of the Renaissance time. And so I'm going to go back and forth to my own history, my own past, but also our own history of modern architecture, and to see how we can learn from it into today's transformation of the industry. So Alberti's theories about le teoria dell'armonia musicale. So he was studying the mathematics of things, and he believed that he transformed the visuals. So he was researching and learning the visuals that are perceived harmonious to our human eyes. And he was looking at endless designs and buildings that were made in the classical times. And he was analyzing it and tried and transformed all of those into shapes and into regularities and basically into math. And he did the same in music. He was studying and researching harmonies that were perceived harmonious to our human ears, and learned a lot and translate those to rhythms and to numbers. And when he compared the two, the mathematics of the visuals and the mathematics of the music, he found out something that really made me overwhelmed. He found out that those numbers are the same, are very, very, very similar, almost the same. And so he also had a building that he manifested his theories. It's called Palazzo Rucellai in Florence, where the facade of that building manifested the harmony of mathematical harmony of our visuals and our hearing. And so years later, I moved to New York City, and I went to architecture school, but I also went to art school. It's I went to the National Academy of Design in New York, and I was learning with masters painting. And I learned how to actually paint with paint with oil or other means, and transform the 3D of the models of the sea life into 2D, into the canvas or the paper. And one of my teacher, a master in realistic painting, kept yelling at me, squint, squint, squint your eyes. So everyone, if you guys will try to squint your eyes, then all of a sudden you'll start to see the 3D space around us in 2D. You'll start to see shapes and colors, and you can start to identify those compositions between the shapes and the colors and the relationship between the shapes. And you can start to transform it to something that is 2D. And this technique of squinting would later become instrumental in my journey to develop algorithms and planning methodologies and try to transform the planning process. And so, as you all know, the process of initial design of buildings is so complex, with a complex constraint optimization problem, if we can define that problem. We have so multidimensional. We have the regulatory ordinances, and so we have building code, and we have zoning, and we have fire code, and we have ADA. And if I forget anything, then please, you guys are welcome to interrupt and ask and add things. So we have, and by the way, I forgot to say that if you have questions, please, you can ask in the chat, and Stacy will can interrupt and ask the questions, or you can just write it down, and we will leave a long time at the end, half an hour, so you guys can ask questions, and any question you have. So feel free to ask either now or at the end of the session, but I would love to answer any question. So let's go back to the design process of buildings. So it's so complex. It's layer over layer over layer for the regulatory aspect, but also the systems. We have so many systems. Building is such a complex organism. We have the structural system, and we have the mechanical system, and we have the electrical system, and we have the plumbing system, and on and on and on. And so layer on layer on layer, I don't need to tell you how complex the process is. And we also have economic factor, which are also complex by themselves, and they coming on top of the complexity that we have, and the market standards, and the market demand, and operational aspects that are very, very complex. And so thinking about all of this complexity and going over a lot of floor plans, starting to think of these huge problems that I described to you before, and starting to go over building designs and floor plans of many, many projects that I was looking at, made me understand, like Alberti, that we can translate a lot of things into mathematics, into rules, into numbers. And maybe that can make a bit of an order with this complexity, with this big mess of all those trades and all those aspects and layers of a building project. And so analyzing hundreds of floor plans and applying the squinting technique. So try to apply the squinting technique even into this and this New York City building, and you can start to identify the patterns and the repetitiveness of the rooms and the dwelling units and the systems. And so that's what we started to do, to just analyze a lot of floor plans and write the regularities, the numbers of every floor plan. And when you started to compare projects, you can start to see how similar they are, even though every architect has their own layers and has their own standards. It's an apartment is an apartment, a building is a building, and there is so much in common that we can actually define or use AI or algorithms to help us make some order in this mess. So inspired by Alberti, we started to simplify the process and to develop the idea of AI-based system for the very initial design process.
So, Dity, we have a first question. They want to know, was the golden mean used by the Greeks included in the mathematical findings?
So, it's not that's not what Alberti research did, but that's exactly the same principle, right? Because it's if we're talking, it's also translating visuals into regularities of numbers. So I think it's not what Alberti was talking about, but of course it's he was influenced. Like that's a similar idea. Is there any other questions?
No, that's all the questions right now.
Okay, thank you. So going now to 2024, back in time, in the time tunnel to 2024, I think all of you heard of the Nobel Prize for Hopfield and Hinton about their discovery. So this is the physics Nobel Prize, but they got it because they are the ones who actually started to the foundation for the current AI transformation, because they studied the human brain and they studied how the neurons in the human brain are connected and working, and they and their theories and their research about that created the modern or today's most common AI that we see spreading like fire everywhere. And it's actually started with this too. So they just got the prize now. Now let's talk about the technologies to track, just for you to be aware of, because AI is a huge buzzword, and we can talk about AI as a buzzword, but just a bit of a dive into the technologies. So when you guys seeing systems, you could maybe understand better how they're working and how you can use them. So if you're talking about the current excitement is around deep learning or machine learning based on neural networks, or NNs, like the one that the Nobel Prize winners actually invented. And the idea is to train data on train on very large data. So you all know probably the systems that recognize cats and other type of animals, and they're being trained on millions of photos, and then they actually understand how to do it. But we don't know how it's happening. We don't know how those machine learns. You train them on the data, but you don't know how they know the result. It's like a black box that we're not sure of what's behind it. And the application of deep learning to vision is what we all see. And now we have the application of deep learning to text, the large language models, the LLMs. So if we talk about the LLMs, it's what everybody knows as the ChatGPT, and it's having great capabilities. So I'm not sure how many of you are using ChatGPT. I would guess a lot of you. And that was trained on millions and billions of texts to learn and to help us with the task we're asking the software to help us. And the both of the last items, they tend to focus on generative application. So generative AI, it's more like when we ask the system to do something, to create something, and we give some guidelines, and then the system all of a sudden create a text for us, a whole article for us. And of course, it can be applied to architecture. If we give some guidance to a system, boom, it will create a new building design for us. So that can be applied to architecture. However, when we thought about that and started to really dig into that, in order to train models, you need data. And even if we talk about architectural plans as data and we start to analyze it, it's a huge problem because, and for many, many reasons, but I'll tell you some of the main reasons. As being architects, you know that your office is using different layers and different standards than your colleagues and other companies. And then how can we use this data if it's not clean, if it's not standardized? So architecture has a major problem with that. Also, another issue is the IP. If we're training a model based on other architects' designs, then who owns the IP for the intellectual property for that models? The company that is training those models or the architect that created those floor plans? So data cleaning and data challenges training models in the architecture industry has major problems, and this subject has not been resolved really. And so because of that, there are other technologies that that might fit better for architecture. So reinforcement learning is when we have an agent, or let's say a player, and we give them guidance to design something. We give a machine instruction to design something. And maybe there's another agent that is trying to design that something, and they got rewarded. So it's like a game. They play, and the one that gets the higher scores is winning this game. So if we talk about two players that are having a task to design floor plans, and then we can create scores to tell them if these floor plans are good or which one is better, then that's also a possibility to create a system that will design or do this automation of design when we're actually scoring the output of the system. Now, if we're talking about constraint optimization or application of computational geometry, then this is very, very good and for the construction industry, for the design industry, because if we're talking about 2D and 3D shapes or translation of designs into shapes, then that's a great way to actually use those technologies to improve the design process. And and if we're talking about heuristic search, then when we started to work, I had a meeting with two engineers, and I was starting to tell them, and they saw that our system automatically designed a building plan, and they were like, "How did you do that?" And so one of the engineers, an older engineer, all of a sudden said, "I know." And then he explained his colleague, and he started to say, "If, and then, if, and then." So if, and then, like a tree of decision, a decision tree that will create designs. And every step you can answer a question, and based on that, create your design. So these open endless opportunities beyond schematic design, I was talking a bit about schematic design or very conceptual planning, but for example, code phrasing, natural language systems, analyzing complex building codes, zoning books, regulatory texts, and extracting the relevant information and constraints as input for the system. So that's not science fiction. We're already there, as you can imagine. And so imagine that we'll teach a system what components like staircases are, egress is, and dwelling units are, and teach them all the if and then for every step of the design process, together with analyzing huge amount of texts like building code and zoning, and how the system can come up with design. So if we talk about health, safety, and welfare compliance, and verifying design complies with health, safety, and welfare guidelines. It's the building code, of course, and starting to teach those LLMs books like the building code. And of course, you can take it on a small scale of a dwelling unit, or a small house, a building, a larger complex, and cities, if you're taking it to a urban planning and large areas to plan. And arcGPT, like chat interfaces for for architects and for architecture. And the sky is the limit for the possibilities in that. I just would like to take you, just to make it a bit more interesting. If we think about the chess, I don't know who is playing chess and following the Lila and Stockfish chess games about champions. But Lila is Lila Chess Zero is only neural network. So only AI, the classical AI of the neural network that we spoke about. While Stockfish is rule-based. The other technology that I described to you were if and then, but with the capability, of course, the huge capabilities of a lot of power. And then they're competing, and they built to Stockfish a layer of neural network on top of the classical algorithm. So it's just an interesting analogy, but I think there's a lot of similarities between chess game and architecture planning if we talk about technology. So until recently, and even today, the architectural design of multi-unit buildings, and when I talk about multi-unit buildings, I'm talking about multi-family, mixed-use buildings, offices that have repetitive sales, hospitals, schools, and larger urban complexes. The way we plan is not very efficient. So I'm not sure how you guys are doing your initial design, but a lot of architects are still using pen and paper and CAD, and for the 2D, and then going to data Excel sheets for understanding and learning the numbers. And that is something that takes a long time in the planning process of a project. And then with SketchUp and Revit, you can have some 3D, but it's spread over a lot of different abilities. And so all of the things that that I described really helped us understand and start to learn and dive better into the AI-powered architectural design tools, and to research more that. And when we started, we were very concerned. Will architects resist the intrusion of AI? So I was very happy to hear when Stacy started that was the demand, to hear more about AI and learn about AI. And I'm not going to teach you about any specific tool, but there's so many tools out there now. And I think that it's very, very important to just hear about the strategic situation and strategically understand better how and what are the ways to think about it and to improve and start to use it for any task that you guys would like to improve in your process. So surprisingly, we thought that architects will hate it and will be very defensive, and we think will be, they will be fearful for their jobs. But we actually, when we started to launch the product and started to talk to fellow architects, we slowly started to understand that architects are embracing it. And, the architecture process is so complex, it's so long, so many hours, with a lot of tasks within those hours that could be automated. So the architecture profession will never disappear, but a lot of the tedious tasks, we can just have some help with this, and maybe have a better work-life balance. And maybe if we have more time, we can invest in the more design aspects of the process, and really improve the design and be able to invest in that, and instead of the tedious work that would be automated. So surprisingly, we met the opposite. We met really embracement from almost all of the architects we spoke to. And again, so we embracing the opportunity to delegate repetitive and tedious tasks to AI system, freeing the time and energy for more creative work, and striving to make our small margin business, because architecture is a very small margin business, and that's very important to be more profitable.
Okay, I have a couple questions.
Sure.
Okay, as it relates to architectural design and AI, how does the if-then scenario play out when there are gray areas of the code or areas subject to multiple interpretations that need to be vetted, discussed, and confirmed with the agency having jurisdiction?
That is a great question, and I think that's a really good question. So in New York City, where I used to work, it's, I don't have to tell you how complex the zoning is, and many times one section is contradicting the other in the zoning resolution. So I totally understand the question, and I have some real life examples for it. But I think that the one thing that AI can help is, when they work on large language models, is understanding those conflicts and making architects and planners aware of those conflicts. I don't think AI will solve them. So did I answer the question?
I guess we'll find out if they respond.
Okay.
There's another, a couple other questions to see. This one kind of goes back to the beginning. You talked about the productivity of the construction industry having not kept pace with other industries. Do you have any data on the productivity of architects alone? It's probably difficult to measure.
I don't have only of architecture, but I think there are from the AIA, I think there are great insights and reports that are very interesting. I don't have them now, and I don't remember the metrics, but I think that's a great resource. If you want to delve more into the architecture specifically, then I think I would go to the AIA report and download it. And I think it's available for every AIA member. And then you can learn from there more specifically about the architecture in the US. I think that's also That's a great resource.
Okay, let's see, there's one, can we quantify imagination?
Can we quantify imagination? So quantifying imagination. So the system that I spoke about are not imagination. They are taken from data. They were trained, even though it's millions and millions of photo, if we're talking about visuals, visual AI, then the system learned it from somewhere. And it's not inventing it, it's collecting it from different resources that it was trained on and creating from that a different being. So it was like a different image or different story, but it was trained on something real. It's not an imagination like that you're a person, you can imagine something. It's very different. Did I answer the question? But it's a very interesting issue that we all talk about. Can AI think? Can AI feel? Can a machine feel? And I think that that's a huge. There are a lot of interesting talks about it. If AI can think, if AI can feel, can computers feel? And so, but it's a fascinating discussion that I don't know if we have an answer for that. That's a very interesting discussion.
We have a couple more questions, 3 more questions. I don't know, do you want to take them now or do you want to continue with your presentation? And
I'm happy to take questions.
okay.
One thing I would like to add to the other question is I read that if we talk about IP, so intellectual properties or patents, there is a huge question now if we can give patents to AI systems. So that's a huge question. If an AI system can invent something new, and if it's patented, if we can actually give them the IP rights, the intellectual property rights that they invented it, and can we do it to an AI system? So there's a lot of very fascinating discussions and about it, and it's a really one of the most interesting topics to read about these days, I think. And yes, Stacey, I'm happy to take more questions.
All right. Okay. The next one is which AI systems best handle sustainability versus cost balancing considerations, and how do they do it?
So I'm not allowed to promote any one system or another, but can you repeat the question again so I can
sure.
be more precise? Thank you.
Which AI systems best handle sustainability versus cost balancing considerations, and how do they do it?
Okay, so that's a great question, but I'm not allowed to, I cannot specify this system or another, but what I can say, the question is the environmental impact when on the design process. So if we're designing a building and we would like to know the environmental impact of that project, so we want to know the winds, we want to know the sun directions in every hour of the day, we want to see the heat, and in order to design better the system or to place the building better, there are systems that are doing it today. I don't know if they're already, it's still under development and improving all the time because we're now on a journey, but it is happening. And cost is, I think it's something that is also happening today. I know systems that can analyze cost of a building design. So you have the building design, and then you would like to know this estimated cost for that building. And there's also a system that will do that. I don't know if which one is better. It really depends on the system and the type of building and the knowledge or what you're really looking for. But both of those abilities are existing already with technology.
Okay, the next question says, we are developing master plan for a small town and creating a 3D digital twin. Lots of AI analytical tools would be helpful to us as designers and to the city officials, developers, and property owners. Please recommend tools for finding relevant, successful examples from other successful municipalities to specific niche issues such as landmark district, density flexibility, architectural character plurality.
So the challenges that you read at the end are could you please repeat just the last
Sure.
aspect?
Let's see, landmark district, density flexibility, architectural character plurality.
So I think there are a lot of systems out there. I don't think this session I could call any specific system, but for making it more dense or more efficiently designed, there are systems out there that could help you to do it. Also on the environmental side, I'm sure, with density, optimize the environmental issues of placing or designing the master plan. There are tools out there. You just can Google it and find it, but are great tools that can help you with that.
Okay, another tools question. Okay, what tools might be out there to integrate AI into project pro forma budget conversations, like stress testing financial models, for example? So it says, for example, what happens if we add 50 hotel rooms to a design?
So, yeah, so I think that's also a very good question. And the answer is similar because if can you repeat the question, because I'm not sure I'll tackle it the right way. So
yeah.
again,
so
thank you.
What tools might be out there to integrate AI into project pro forma / budget conversations, stress testing financial models, for example?
So if we're talking about financial models of a building, and it really depends on the type of building, if it's a house, if it's a multifamily, if it's a school, if it's what type of project it is, but it's in terms of cost and actually ROI, what you can actually gain for such a project, then there are systems that needs to get as input the design of that building, the system that we're going to use, and then the cost, and then the income, the projected income for such type of buildings. For example, if it's a multifamily, then the price per square foot for every unit type. If it's other type of buildings, then it's a rental, it's a condo, it's affordable housing, whatever type of buildings you're talking about, you'll need to know the costs and the profit of that building, and then have that analysis. And with today tools, you can just do it. It of course depends on the type of buildings. It's a general question, and I cannot answer and give you one name of tool, but it is doable to do it, and you can get a lot of help from tools to have that analysis, the ROI analysis of a project.
How do we deal with AI hallucination?
So, so I'm going to talk a bit about hallucination a bit further in the talk, but hallucination, or like when you get AI that is, you can actually ask AI question and it will give you the most ridiculous answer. So on one hand, you can ask a question or ask a system to create something, and it's amazing and perfect, and it saves you a huge amount of time. And on the other time, if you ask them who is the writer of that book, they will give you, like a joke, wrong answer. And so I do think that the role of the humans is still crucial. And so definitely if we talk about the architecture industry, and definitely if we talk about health, safety, and welfare of the public, humans are not being replaced. I don't see that yet. And so, AI system are having a lot of hallucinations, a lot of mistakes, a lot of things that we shouldn't count on, unfortunately.
Okay. The questions keep rolling in. Do you want to continue with the presentation, and then we'll kind of go to some of these later in case you address them later?
I'm happy to answer now, and then
okay.
Yeah,
all right. Okay. I see the benefit in time savings and profits for the owners of the architectural firm, as well as the company producing the software. But what is the benefit for the young architects in need to understand and grow in their professional pursuit? Why do you believe the optimization means speed?
So actually, I just gave this talk in Florida University, and so I had the same question there, and there's a lot of knowledge in AI systems, and I think that young architects actually are the one that can gain the most, because if you are getting a ready-made design with a lot of code compliance within, then you learn from it. And you don't need to go and search forever for those answers and need favors from older architects to sit with you and help you and teach you. But you can learn it yourself by analyzing software outputs. So I actually think that it's actually making the life of young architects better. I do see young architects that will be the early adopters of technologies, and because they actually going to be the ones that I believe would gain much more than the older ones. Because an experienced architect knows all the answers. I know, what's the egress distances. I know what the formulas are, and I have a lot of experience. But when you don't have it, and you can learn also from AI, and that's where I think it's very powerful for interns and young architects.
Okay, so, my client uses AI to generate images of her desired spaces, which she then shares with me. What are the industry trends toward AI's use by team members other than the architect?
So that's a great question. And in New York City, we work with a lot of companies that working with real estate developers. And when real estate developer is starting a new project, then they don't have a way to analyze and know what they actually can build there until they go to an architect and hire them and ask them to do a design for that building. And then when the architect is coming back with, after sitting and creating and working hard on this design option, the client will say, oh, that's not maximizing my ROI that we spoke before, is not nice design, or I don't like it, please try another option. And the architect will go back and work again for hours, for days, for weeks to create another design option. I don't think that this client will pay for the hard work of the architect that again and again and again try to satisfy the developer or the client. So I do think that maybe now, if a client will have a tool to convey what they want themselves and coming to an architect with a better idea, I think that could do better. I hope so. That's my hope. Or if you want a a different style, and as a client, and you're coming to an architect with already knowing the style, it might save a lot of efforts from the architect end to understand what the client wants and coming, back and forth with the different designs every time. Whereas when the client will be more in the process, I'm hoping that will improve the process of design and the architecture work. So, but I think it can be huge from actually having the client to be part of the design or conveying better what they want from the architect.
Do you feel the generation gap between young architects and older architects will increase due to AI? And how do you feel this will affect the intern and principal relationship?
So, so what I see is more younger architects are adopting AI or more open to it. But I do think that it's just a huge opportunity for older architects, because unlike Revit, for example, that is a very, very complex tool, right? I'm sure a lot of you know Revit, but a lot of you don't know it or don't manage to work with it because it's complex and you need months of training, and it's not very democratic, right? If only several people can work with it because it's complex. AI systems are much easier because a lot of it is automation. So I do think that it will actually have also a lot of potential to help older architects it's difficult for them, but having challenges adapting into new technologies. I do think that AI could be adapted easily than other technologies because of the automation aspect of it.
Okay, and then here's one. Let's see. If you're incorporating code analysis into a project, are you able to also incorporate local amendments to the code?
That's a great question. That's if we talk about building code, and local is more zoning ordinances, right, of different localities. And so I think that little by little for now, because we're just in the beginning of this transformation, we're on a journey and it's just starting, and there's still the potential, and there's so long way to go. But I do think that for now, we can see something more general. So if a system includes within compliance to a building code, like the new International Building Code, where it's more on a larger scale, then if we talk about smaller municipalities, smaller places, particular zoning ordinances, then I don't think it's possible to do it now, but I do think that when it will be more adapted, when it will be more popular and adopted everywhere, then we can see more small localities zoning and being also trained and included in those systems.
Okay, and then another one on code. So researching codes is valuable and a large part of professional responsibility of an architect. How does AI making code interpretations allow the young architects to truly learn the codes and apply the codes to design? And how will AI take liability for code interpretation if health, safety, and welfare is compromised?
Wow, so that's great questions. Thanks, everyone. You guys are asking amazing and fascinating questions. And I'm really having fun to think about it. So if we're talking about young architects that need to learn building code, and the question is, if they get it automatically, how can they learn? Is that I assume that's the question?
Yes, that's
right?
the question.
Okay. So I do remember myself as a young architect trying to learn building code, and I think it is so complex to understand a lot of it, that I hope and I do believe that technology can help us to learn better building code, because if it's so difficult to understand the formula of, you know, thread and riser, even, that I'll talk about it later, we can use systems to do it, and or for us, stuff like that. And we can also learn from system, because the systems would simplify a lot of it, and it would be easier for us as humans to comprehend it. All this, we spoke about the complexity of it, and so we can have the help of a system to analyze it and simplify it, and also check code compliance. So systems can really do a great job in helping us to analyze code compliance, giving a system a floor plan or a certain design, and then the system can go and check where it's not complying, or when there are clashes in the systems, and, you know, and later it will be huge problems in the construction because of that. So I do think that we need a lot of help as architects, and if we can get that help from technology, then I do think that everyone should start really learning about it and getting that help. But yeah, I think that for young architects, it's so complex. I was just talking about, I'll show you later, a project by Fariba McCoy, who's a very experienced architect in New York City and owner of Fisher McCoy in New York. And she's talking about the complexity. And she's saying that when she was young, she hated it, that it's so complex, because she couldn't really understand what she needs to do. It was so complex and frustrating. And now when she's older and she's so experienced, she actually embraces it. She loves it, because that's what makes it so interesting, that, you know, the challenges that we have. So as I said, my hope, and I do see the potential of systems to help conveying complexities of building code and other ordinances to younger architects, to and help them to comply, to understand better, and to be able to start designing faster.
And this is the last one, then we'll let you continue on. Do you know if architectural schools are incorporating AI into their curriculum?
So yes, I meet with a lot of universities, and a lot of them are starting to understand that our industry is going through a major shift. And I showed you the metrics before, that our industry is behind, but we don't want it to be behind. We want to be, you know, we're architects, we want our industry to be at the forefront. We want to lead, and we're lagging behind in any possible aspect. And so I do hope that this transformation that is going through will be adopted by universities. And I see that a lot of universities are having technology master plan, you know, masters and stuff like that. So that's being adopted everywhere. Yeah.
Okay, let you continue on.
Okay, thank you guys. Thank you for really amazing questions. I hope I answered, and if not, then you're welcome to ask me at the end. Like I said, I'm really enjoying it. So let's talk about a story. I would like to tell you a story, personal story from the university. Like I said, when I was in Florence University, I have a friend, and her name is Giulia. She's from Bologna in Italy. And we did a project together, Analisi della città e del territorio. It was in Bologna, and I used to travel to her home all the time, and her family is amazing. They were hosting me, and her dad was an architect, and her mom was cooking great food. And one time I asked her, Giulia, what does your mom do? What's your mom profession? And I'm reminding you, it was 30 years ago. And Giulia responded, my mom is the wife of the architect. Sorry. My mom is the wife of the architect. So the wife of the architect 30 years ago, anyone is having idea what it was? Just in the chat, Stacy, if someone can guess. Okay, I see no guesses. Okay. So 30 years ago, when I was in university, then the AutoCAD was not spread. We didn't use AutoCAD. We used pen, and we drew with a special pen, and so Julia replied to me, my mom is the wife of the architect. And when I was naive, like you, I didn't know what it was. I see people are starting to answer. So is there an answer, Stacy?
Just a second here. So,
Thank you.
yeah, there's assistant architects, they trace lawyers, draftsmen, drafter.
Yeah, great. That's correct. So I didn't know what the wife of the architect was. And then I asked, I'm not coming from architect family. And then Julia explained to me that the wife of the architect, because we were drawing with pens, the wife of the architects were the one who were masters of drawing these millions of dots to draw grass and millions of lines to draw the leaves of trees on floor plans and construction plans. And they were the one that drew, the million lines to make the stone facade on drawings, because it was all manual. But 3 years from that talk, 30 years ago, with Julia, everything was changed. And AutoCAD was starting to spread everywhere. And the wife of the architect was completely changed. And so I think it's a lot of it, like our work today as architects, all the small designs that we're doing, every unit detail or every unit at a large floor plan that I'm designing, and every elevator that we're placing, that is going to change probably 3 years from our talk now. So I think that's, if we're talking about the role of architects, architects are going to still design the buildings and are still going to manage that process, but we'll need to change the skills. And so, we remain essential in reviewing, in selecting, in customizing AI generate outputs to align with project context and specific goals. But a lot of things are going to change. So that's actually the transformation. So we see already a lot of tasks are being changed. AI tools like ChatGPT and generative design platform are transforming a lot of the flows already. And we leverage AI for administration, a lot of our administration. And like I said, I'm hoping it would boost creativity, productivity by handling the routine, boring, tedious processes. And there are other ways to, I was talking about the initial design stage, but it can predict materials, it can update BIM, like assess clashes in the design of the system, and manages drafting and scheduling. But while offering new opportunities, AI also raises questions about automation in architecture. And so, like I said, there's a lot of advantages. It's instant. We can do stuff up to code once it will improve, optimize multiple options. It takes us forever to design one option, but a system can do it millions of options and on the spot. And the workflow can be also connected to other means. But we also have to talk about other aspects. Now, I spoke about Fariba before. This is a project that Fariba created in New York City, and all the use cases I'm going to show you are from New York. So she's She's on 2022. She was the 7th largest in New York. She's the owner of Fisher McCoy Architects. And if you look at her floor plans, you can see issues like egress distances. You can see stairs. You can see clearances. You can see dwelling units, that all of the dwelling units has access to legal light and air. In this floor plan. And if we're talking about zoning, compliance with unit counts, with unit area, with lot coverage, with base height, with so many aspects of building code and zoning. And so this is a project by Sam Weider Architects. He's the 3rd largest in New York City for 2022. And this is also a project that was created with AI. And again, building code, egress, stairs, clearances, zoning, comply with unit count, unit area, lot coverage, building and setbacks, and all those issues. And so enhancing architectural design through AI, prioritizing health, safety, and welfare. So I showed you the examples that are real projects that were designed with AI, and we're hoping that it will increase or enhance the occupant well-being, the public well-being, streamline design for better health, safety, and welfare, and redefines traditional approaches to prioritize these outcomes. And it's not only about time and labor saving, it's also about better space utilization, because computers are better than humans in optimization. So I spoke before about mathematics and optimization problems like design of urban buildings, and computers have much better capabilities than us for optimization. And if we talk about space efficiencies, it's critical for us. If we're looking at housing is a basic human need, and rapid urbanization is happening. We need to build 96,000 new homes every day to house the estimated 3 billion people who will need adequate housing by 2030, which is almost now. Now, by 2025, 1.6 billion people are expected to be affected by the global housing shortage. And there's a lot of talk about the housing crisis in the US right now. The United States alone is short of 1.5 million homes today. And demand and efforts to develop sustainable, inclusive, and affordable housing solutions to cater to diverse needs of communities across the world. So that's us, a profession, as industry, that's our major challenge. And we're talking about only housing, but think about the infrastructure and the other buildings that need to be also. We start with housing, but also schools, hospitals, and so on. So we need to build a lot of buildings, and we have a lot of responsibility to make it better, faster, cheaper, more sustainable to the public. And now we're getting into things to watch out for. And you guys were talking about hallucinations before, but also unpredictability. Non-explainability. So we don't know why the AI system decided to spit a certain output, and it could be ridiculous, and it could be weird, and it could be wrong, totally wrong. And we see it. All the users of ChatGPT know it and can experienced it firsthand. Now, we also have a lot of issues that everybody talk about. If we talk about OpenAI, if we talk about other LLMs development or AI development, privacy, bias, toxicity, it's there. We hear about it all the time, every day. And intellectual property. Who owns the intellectual property of the outputs of those systems? That's a huge question, because those companies are training the LLMs, the large language models, on the internet. And who owns those intellectual property copyrights? These are not only issues of product quality, but also legal liability. Oh. Do you see my screen?
Yes, we see your screen.
Oh, okay. Okay, sorry. So, sorry. Okay, because it says that my screen sharing is paused. So, things to watch out for: challenges and opportunities. So nothing is great. I'm an optimistic person, and I try to look at the better side of technology. But of course, AI for architectural design faces several challenges, and instances of AI generate false outputs, such as those seen with ChatGPT. We have to, implement safeguards, and we really have to watch out for it and know that it will also be there. Now, professional liability. As human architects, given the so who has the liability? And I have bad news for everyone, because I do not believe that an AI system will take your liability. So the liability will still be on us human architects. And any help that we get for such a system, and I hope it will be huge help for all of you, still need to be watched, and we have the responsibility for due diligence, for understanding potential pitfalls, and all those issues are still on our shoulders as architects, as human architects. Copyright issues. So I spoke before about copyrights. Who owns the copyrights generated by AI? The tech company? And I remember we also had some questions about that. The tech company generated by AI, or the human architect who inserted the input and generated a design, not to speak about even the data that it was trained on. So AI has the potential to level the playing field among architects of varying experiences level. And there were questions before about junior architects. They can learn to design faster or earlier with those systems, and enabling them to benefit from the outputs.
Dity, I wonder if our screen is stuck. The slide that we all see now says things to watch out for.
Oh yeah, that's why I think, let me stop to share. I don't know, because it says that
Yeah, maybe stop sharing and then
okay, sorry guys.
and then try again. Yeah.
I'll try again. Yeah. Okay, now you see my screen?
Yes, now it says navigating complex building code regulations.
Yeah, so let me get back to the screen, because I was talking and you didn't see the slides. So I had a note that it was a stop share, but so this is the slides the last slide that
that's the last slide that we saw.
And that's the one those were the slide that I spoke about liability. I'm really sorry, guys. That's the other one that I spoke about copyrights. And now I'm hoping that you guys are with me. What does all this means for architects?
Yes, we are with you.
Okay, great. Thank you for that. In a word, we must become AI literate. And so navigating complex building code regulations, for example, ingress compliance. So if we talk about egress compliance, and that's just one example that I'll talk about because it's very easy to demonstrate it in floor plans. So that's a process that we have to make sure that all the exits are complying with the egress requirements. And so for a machine, it's something that is doable to do. It's very easy for a machine to learn those regulations and actually either speed the design that is complying or look at your design and help you to make sure it's complying. So when we're considering maximum distances between means of egress in floor plan layouts, that's easy for algorithms to verify compliance for your plans. Now, for example, if we're looking of safety, so during emergencies in egress, that's you can check that. And algorithms, and we had the question before, Stacey, that algorithms adapt to diverse jurisdictional standards. And so, for example, I'll give you examples that I saw. So in New York City, the dead-end corridor, the maximum allowed dead-end corridor, I can show you after that on plans, it's 80 feet. In California, I was told it's 50 feet. So that's something that is very easy for a system to learn and to detect and to help you understand if your very complex design is complying. Now, AI can play a crucial role in optimizing staircase. So for example, staircase, the formula of thread and riser, the railing, the path, clearances, and all that, that's easy for AI to make sure or to speed a design that is complying or to check, verify that your floor plan is actually in compliance. For example, if we talk about the health, safety, and well-being considerations, we spoke before about safety, egress, but if we talk about ADA and clearances, so we need to know that the radius for wheelchair will be complying in the floor plan of the dwelling units or any other building type that we're designing. And so algorithms can take all that complexity and spits design that are complying with that. So and making sure that wheelchairs the path and the radius for the clearances will be all complying. And that's just a picture of our system when we started, was that we checked that the dwelling units and then entrance clearances to every dwelling unit. And so we talk about egress, but ADA and building code and a lot of things, layers over layers that systems can help us to do. This is a building in New York, the zoning for example, in New York City. So we have the lot area, we have the lot width, we have the rear yard regulations, we have the lot coverage, the floor area, the base height, building height, the number of stories allowed, the dwelling unit factor, how many units we can create on a different property. So how many parking are required on different property. And all that are numbers, are very, very easy for AI system to help you with. So in New York City, we have the quality housing, which is context zoning, and we have the height factor buildings. And many times, developers and architects are debating which is better for a property, for which system it's better to develop that property, height factor or contextual building. And so AI system can speed designs very easily and can really help you with those metrics. You need to know what can you do with a height factor building within the regulations and the zoning that we spoke about, or quality housing. And that's something that can really help at the beginning of the process. Now, for example, if we're talking about enhancing architectural design through AI and health, safety, and welfare prioritization. So, for example, you have rear yard distance should be 30 feet. So a system can place a building with a 30 feet distance from a rear lot line. If we speak about lot coverage, how much from a lot you can cover for your residential portion, that's easy for a system to automatically make it. Street wall. So in New York zoning, you have to build on a street wall in order to preserve the street wall for contextual buildings. And so it's easy for a system to understand if you need to align to the street wall, if you need to align to the adjacent building, and all that conditions. A system can spit a lot of vertical cores design options. So if we spoke about egress and distances and building code. If we're placing elevator in a building, it's not so much about building code, because elevators are not legal means of egress, but you need to know that the building occupant, the people that live in this building, or the people that work in that building don't have to walk for an hour to get to an elevator, right? So it's also things that are more that system can help us with the well-being of the public. And if we speak about legal light and air, for example, so there are the requirements for legal rooms, and those legal rooms in dense urban areas need legal light and air, or need to comply with legal light and air, so the legal windows can be placed on different facades of the building. And those facades can be either the street wall or legal backyard or rear yard that are complying with the metrics from the zoning. And so a system can understand, or you as a user can input which walls are window walls, are legal, that will provide legal light and air to your building. And the system can automatically place the legal rooms along those walls, and can also place the dwelling units accordingly. And so if we talk about AI, for example, I'll give you a use case just for you to understand more in more details how the process is happening. So if we're designing a floor plan of a building, of a typical floor plan, let's say of a multi-family building, the area must be connected to window wall. The area of the dwelling units must be, like I showed you before, connected to window wall. Those units that are going to be designed in that area, every unit must have legal rooms, and those legal rooms must have light and air and comply with the light and air requirements. They must be connected, every dwelling unit must be connected to a corridor with the clearances that we spoke before. So when you go into the unit, some distances, certain clearances and distances must be met. And so the AI will not work if that is not happening, if those units cannot be connected in a legal way to a corridor or a lobby or a legal means of egress. And other condition, for example, that must be met is, well, I lost it, all right? Okay, if the vertical chords could be, okay, yeah. And the third condition is if the public vertical chords, the stairs, the elevators are connected to this public access corridor. So, so everything must comply in terms of building code, egress, and ADA, and it's all things that could be designed by systems. And that's use cases that I can show you. So this is a multi-family building in Bedford Avenue in New York City. And that's By the way, this is just, we played with the AI for rendering, so you can see renderings, but it's not connected to the health, safety, and welfare, so I will not show you examples, but that's another way of helping yourself, just getting really fast sketches of the massing that you want to show the clients, get it through one of the AI systems for renderings, and then get show some different styles to your client. So this is a 9-story building with a 320 units building in New York. And you can see setbacks is something that can be utilized or assisted by AI, where we need to do the setback to a building, how we're going to do it, and so on. Or if you have the sky exposure plane in height factor buildings, that you know the angle that you need to do. And if we're talking about the uses, different uses of a building, you are allowed to build different uses, and systems can verify that and make sure that all the uses are according to the legalities. And so those are floor plan of the buildings, and this is the first floor, and the system can see if all the staircases that are coming from the residential portion of the building and are complying with the egress requirements. And if we're looking on this floor, you can see that we have some lobby here and some also, and you have to make sure that everything complies. So all the dwelling units have legal light and air, are planned along walls that provide legal light and air and have access to corridor. And we spoke before about the dead-end corridor distances, so it's not over 80 feet. And the distances to elevators are not more than certain distance. As I said, not before because of building code, but more because of well-being of the occupants. Those are plans that were planned with AI. And like I said, we have conditions. The AI will not just spit something. You must meet these conditions. So in this case, the area must be connected to window walls. And like I said, all the units must be have access or legal rooms with legal light and air. And so if we ask the AI system to comply and design a building here, it will not work because it's a black wall, it's a block wall. We don't have, it's not a window wall. And then the AI will never work and will never design the dwelling units in this area. And if we changed it to window walls, the light walls, then it will work, like in this example. So this is a building in Broadway, New Jersey, and it's a 12-story, 136 units. And as you see, the AI can calculate all your calculation, the distribution, the percentages of different unit types, studio, 1-bedroom, 2-bedroom, 3-bedroom, make sure that the areas of every dwelling unit is according to the regulations, but also to market standards. So a condominium building in a different area will not be the same as a rental in other areas, and affordable housing in other projects. So let's look at this project. That's the seller plan of the project. It's a complex project. That's why I wanted to show it to you. And with different uses, parking, residential, and the typical floor has dwelling units along the window walls, and you can see it doesn't place rooms along the block walls or the lot line walls, only along the legal light and air walls. And it can spit different types of units for every floor type according to your input of market standards or zoning And if we're talking about another case study, the dwelling units areas must be connected to a corridor, lobby, or egress to comply with egress regulations. So we have to, it's not only egress, like I said, it's also ADA and other ordinances, but of course it must be connected to corridor, it must be with legal means of egress, and must comply with dead-end corridors that we spoke about. And for example, if you try to ask this floor plan on the left, if you ask the AI, you see it's not working. You'll ask the AI to generate for you a floor plan of this floor plan, this typical floor plan, it will not work. Only when you give access to these potentially plan units on the right, on the example on the right, then the AI is turning blue and will work for you. The button will work and you can plan those units. That's another building also in New Jersey. So not only New York, also New Jersey. And you can see that it has 288 units. It's a mixed-use building and of 17 stories. And you can see it's that's the mixed-use floor. So we have also retail, and it's also designing mixed use into this building. And the egress is also on the first floor. You know that all the staircases and everything is complying like it should be, with exits to the street. And this is the residential floor, and with the units. And if we want to say that if we're talking about, and that's amenities and for the building, and everything is being planned with AI. And that's an example where shafts and vertical cores, they must be connected again to the corridor. So not only the dwelling units must be connected to corridors with the comply with clearances, with egress, and with all that, but also the vertical shafts, of course, the elevators, the staircases, and everything. So if my staircase, for example, with the door is not connected to the corridor in the right way, and I'm asking to design only this portion of the building to dwelling units to design it, and so the system will just not work. Once I connect it the right way to the lobby, or to the egress, or in this case to the corridor, then the system will work and will design automatically the dwelling units. Now, we spoke about building setbacks, for example. So we need to comply with the sky exposure plan. And of course, if we're talking about setbacks, it's, again, New York City, if the buildings or the areas that are built with really tall buildings have very little light in these streets. And so in order to make sure that we will have light to the streets, they created the sky exposure plane, but also the setback regulations in the quality housing buildings. And so it's all about geometry and metrics and numbers that are in the books and as a text. And so it's very easy for a system to interpret that and create complying speeds, complying outputs for those regulations. And so again, from New York City, the height factor, the contextual zoning with high limits, with lot coverage for the contextual zoning, and other height factor for the height factor building, street wall that has to align to the adjacent building, and so on. And systems are already complying with that, and speeding designs that comply with that. So that's a building on 15th Street in New York City, 9 stories, 44 units or smaller scale building. And we're complying with the contextual building with a setback that is required here, and the parking area that is required here, and it's a commercial mixed-use building, so we see the commercial area that also needs to comply with the floor area that is permitted for the commercial portion of the building, and has other regulations, including access, that is within the text, and so systems are already can spit those or input output those. And as you can see here, we have also, when we're designing buildings, we have courts, we have inner courts and outer courts, and they have different proportions, and it's not always permitted, and so systems can make sure that those courts comply with the proportions that are allowed by the zoning for inner court or outer court. And you can see here we have again the dead-end corridor, which is and a system can measure this distance, and we have the scissor stairs that is very common in New York City, that is also needs to verify that it's complying with the building height, with the floor height, and so on, and systems can do it really well and save us a lot of work. So yeah, and now that's, for example, before doing the AI generate, we explain the lot coverage, we give the system some information that we want, and then the system will spit the setbacks, the courts, and the dwelling units layout for that building, and make all the calculations and make sure it's complying with your design. So we're optimistic. It's corny, but it's true. The slogan that they say about doctors, that AI will not replace architects, but architects who use AI will replace those who don't. So I really happy and thrilled that so many of you joined this talk. And I do think that it's crucial for us to start. And like I said, I didn't give any name of platform, but it's very important for us to start learning in a strategic way. And that's why I spoke about the technology and the opportunities or the potential, and think of the task that you really need help with in your practices, and start to research and think about the technology that we spoke about. How can it help you? And I'm sure many of those tools can help you. So can save you a lot of time, and maybe help with your life-work balance, and maybe make your practice more profitable and more fun. And so I really hope you guys will start to dive into that. And yeah, and I'm really thanking you for joining. And like I said, that was a HSW, Health, Safety, and Welfare lecture, and that's why I kind of try to stick into that. But I think there's so much in that and more. And yeah, and I'm open to questions. We have 20 minutes, so I'm happy to hear other questions, and yeah. And thank you so much. And I would love to hear from you. That's my email, and I would love any insights and requests and so on. So thank you so much for that. And I'm open for questions.
Okay. So one of our questions was, how will AI affect smaller companies? Is the cost to maintain the license for some of these platforms prohibitive?
So how will it? So a lot of tools are free, guys. A lot of tools are free. So I think a lot of tools have the mission to make architectural design accessible, especially to smaller firms. And so many of the tools are free. So I just really encourage you to check it, because I don't believe in buying something before you test it, work on it, get a lot of value for it, work on it for a long, long time, and make sure that it's saving you and bringing you a lot of value. And only that, after that, start to pay for it. So I do think that today's AI environment is really for that. And many of the tools are free. So I really urge you to start to try and enjoy it and improve your practices. And I do think that for smaller companies, it's even more important. So I think that there's a lot of potential for you to improve there.
Okay. So, how do you manage the data context window that your AI model uses to eliminate false outputs during the iterative exploration process of optional design solutions?
So, like I said, the responsibility is ours. We have to make sure that things comply, the designs are good. It's like we're getting the bases or templates from the system, but most of the system will enable you to edit it and make sure it's comply or with your vision and with your design. So it's just enabler, it's just helper, it's your assistant. But and you have to check everything a system is doing and go over it yourself and make sure that's a design you were meaning to generate. And whatever is not, you need to edit it. And I think when we started, our system was very stiff and we didn't allow anything that is not complying. But then architects couldn't work with the system because it was so stiff. So we had to understand that you guys are the designers and you guys are responsible. And to trust you to be able to edit everything, because I think it's a mutual work. It's a common work of the architect and the system. It's not only the system. It's always a mutual creation.
How is AI assisting in structural frame geometry simplification?
So I'm not a structural engineer, but there are systems out there that trying to help with the structural aspects of building design, and it's still not there. Like, it's still like architects that we have the liability, structural engineer are having the liability, and I think it will always be like that. But I think the system can also help with structural aspects of planning. And so there are systems and tools out there that could be a help for the structural aspect of design. But of course, it's still, nothing is bulletproof. Nothing is, everything you need to check and edit it yourself and make sure it's complying.
So the constraints and the codes, the different parameters that you put into the systems, are they automatically integrated, or are they manually input by the user?
So I think it depends on the system. Every system works differently, and it depends. So some systems, certain portions are the input and others are the output, and in other tools it's different. So it's very, very difficult for me to have one rule of thumb. But I do think that one rule of thumb is that you need to set the conditions to the system. You need to say to the system the address, the municipality. Sometimes the zoning is the input for a system. It depends. It really depends on the system, on the type of building. For example, our system works only for multi-family, but I see users that are doing schools with it. So, it wasn't meant. It's not the right fit, but still people are getting value in doing it. So I think it really depends on the system. We're still very early in the process of that transformation.
Many owners don't understand how much is involved in the process of producing documents. As a result, there is often pushback on our fees. How do we avoid the perception that AI will make the process easier and further the battle of our fees? Likewise, how do we avoid the perception that AI allows anyone to do our job?
That's a great question. So I do think that one of the problems of our industry is that we're not being appreciated enough. The amount of work that we're doing is very difficult for clients to comprehend and understand, and therefore it's always an issue. It's always an issue that they don't see how much work we put in to phases of the process, like the documents, but also the initial design and also the construction management. So each one of these phases requires a lot of time. And if you divide architect's fee to the time we invest, it's a problem. So again, I think it's really important for each of you to understand what aspects of the process that you're really passionate about and try to make this, to find the way to make those more time for that, to spend more time with that, and find tools to help you to do the stuff that that you're not passionate about and are not helping or more tedious. And as to the clients, it's a problem today. Maybe it will stay a problem. I don't know. Maybe if we spend less time in tedious work, maybe that will be true, that, you know, but they believe that we spend less time. But yeah, that's a major issue today in the industry.
So I had a couple different questions. People who do different types of projects, single family residential, remodels, things like that. Are there a lot of tools out there for different types of architecture?
Yeah, so I think it's by the type of building. If you're talking about the design or initial design stages, but other ways, other processes in the architectural design. I think that, you know, if we talk, I showed you the metrics before, how much we're behind. And so if we're taking the medical industry, the medical vertical, for example, before there was a doctor, a general doctor, right? So every type of disease, every type of issues were resolved by one person, by the general doctor. And as the industry progressed, there were more specialized people that would specialize in different diseases and more specialized. So today it's not only about disease, it's also within one disease, there are many types and many specializations and specialists. And so, and now it's even by the patients. So, you know, this is an industry that is way advanced than the construction industry. And today when we design and build a project, we design and build single family, and we design and build hotel or, you know, a university, we use for the design process and also many times for the construction, we use the same technology. But if we'll start to be more specialized for and treat every building as an organism as very different, and the design technology that we use for such a building typology will be different, then that's where we start to really improve our industry. So I do think that it's going there.
So this one says, can you share any examples of different solutions from the AI for one of your projects? They're curious about how many different options are generated.
So that's also a great question. The projects that I showed you are from the system, but at the beginning, it was so many that it was impossible to comprehend. But then imagine how difficult it was for the user to start selecting, because you had to go into every design option and understand the differences between every design option. It took forever. It took more time than designing. So when we got improved better and better, you start to teach the system, like we said, scoring. How do you score better design? And then the system will offer you options that it thinks that the system think are better for the input that you inserted. So that's actually becoming better and better improving the system when you are starting to offer the user less design options.
Are code officials utilizing AI in plan review?
Code officials, not in New York City. No. We actually meet with code officials. I met with code officials. We were discussing a lot of it, but it's still, I think that there will be the last to adopt. It will come from the market. It will be very much spread, then that's when the code officials will have no choice and will start to also use it and adapt. So, yeah.
How many tools and programs are there existing right now for building code review and analysis?
Code review analysis. So I'm not sure how many. I have no idea. Like I know it's happening. I know some tools. There are also, different type of code analysis. So you can have code analysis where there's a tool that will just bring you the text really easily. And a lot of architecture companies are using this. So you're looking for something in the building code and it will give you the right section immediately. So there are tools like that. And there are tools that actually automating, implementing this text in the design itself, which is more rare, but there are also tools like that. And like I said, tools that aim to check this compliance. So a lot of tools are tackling this problem from different perspectives.
Okay. Do you think that AI will make us more creative or less creative? Is there a danger that reliance on AI solutions will limit design variety?
So I think it will make us more creative. Because it would take the tedious work and we will have time to be more creative. I strongly believe in that. What was the other part of the question?
Will it make us more creative? And let me find that again. Is there a danger that reliance on AI solutions will limit design variety?
So yes and no, because if we're looking at the CAD transformation of the industry, then I think it made a lot of buildings similar because we use the same design technology. But on the other hand, if we will have various design technologies or different design technology for different typologies of building, then that will make us more creative because for example, if we look at our cities and if we look at urban areas, high density areas like New York City, we have limited space there and limited design options that we can do for every property. And it's all because it's a city with blocks and we have the front and the rear and we have limited FAR, floor area ratio to build, and limited heights. So the variety is, we have to optimize for the well-being, of using this air rights in a more efficient ways. That's our responsibility for the clients, but also for the environment. But if we're doing a museum, then that's where we can really be creative and different, and we can use different tools and make it totally different, because that's where different type of creativity is important, not so much the optimization and the well-being of the habitant, but more bringing creativity, inspiration, and enjoyment of art. So it's very different. I think that the more we'll be better industry, the more we specialize on different design technology and different tools. So yeah.
Can AI work at the detailing level, including variations for flashing configuration, waterproofing, membranes, insulation, fire stopping, such as designing windowsills, parapets, and cladding detailing?
Yeah, so I do think that it can help tremendously in doing this. I already know some tools that are doing it. And yeah, it can help with detailing. It can help to detect clashes or details that are not wrong, that are not well designed. That would be major problems in the future of the process, in the construction side, that will not work and clash. So yeah, there's a lot of tools that can help with that.
A lot of people are asking what platform you use to create the examples you showed. We understand you're not recommending it, but they are just curious what platform it is.
So I think I'm not allowed to say, so I'm not going to. Sorry.
Okay. And
You tell me. I know it's an AIA course, so I'm not supposed to promote any.
okay. And I think that, and there's a couple questions also about, again, wondering about linking the local ordinances and how that works to put your local zoning and code ordinances in.
So I think at the stage that we're at right now, it's still there's still, I don't know, any platform that is adapted to a city, except actually New York City, because it's a big city. So we had one platform that was specialized in New York City. But I think that once we'll progress in developing those AI systems, we'll have the capacity to really concentrate on different localities, and that's when you'll have the zoning or local zoning of every municipality within systems.
The examples shown in the presentation were very rectilinear. Can this kind of software consider more complex geometry?
Yes, the answer is yes. The systems can create depends on the system, depends on the locality, depends on where the system is planned, but system can have, in general, systems can have different capabilities. And if we go back to the technology that we spoke about, that's computational geometry, and systems can work on different dimensions in 3D and 2D and have very complex